Welcome to The Explainer. Today, we're zooming way in on the absolute ultimate physical comedy trope. Yep, we're talking about slipping on a banana peel. We're going to unpack the surprisingly deep history, the literal physics, and the really fascinating psychology behind this iconic gag. We'll be looking at everything from those very early stage acts to the wildly exaggerated graphics movements in modern animation, right down to the microscopic friction that literally makes a slide happen. Okay, to kick things off and set the perfect vibe for this, let's look at a quote. A banana has two uses, food and entertainment. That brilliant little line from Garfield, way back in 1982, perfectly frames the banana peel. It's not just garbage, right? It's this legendary, multifaceted comedic device. So here's our quick roadmap to rigorously deconstruct the anatomy of this gag. We're hitting the art of the pratfall, a very slippery history, cartoon physics and graphics movements, scoring the slide, the actual science behind it, and finally, the psychology of laughter. Starting right off with Section 1, the art of the pratfall. We've got to begin with the physical reality of the gag itself. It is genuinely wild to realize that slipping on a banana peel wasn't originally a joke at all. It was a very real, very dangerous public hazard. Think about it. In the mid-19th century, bananas were being imported into New York City, and they were this hugely popular street food. But, well, without modern sanitation, people just kind of tossed the skins straight onto the ground. As they rotted, these peels turned into literal slime-covered booby traps on the sidewalks. By the 1880s, Sunday schools were actually warning children that stepping on a peel would lead to broken limbs and a life in the poorhouse. No joke. It really wasn't until the 1900s on the vaudeville circuit that a comedian named Sliding Billy Watson saw a man wildly flailing his arms to stay upright after stepping on a peel. Watson took that frantic, kinetic character movement and turned it into a massively celebrated stage act. And those kinetic character movements, they transitioned absolutely flawlessly into early cinema. It's a pretty simple equation. Physical comedy plus silent film equals silent comedy. Because early films obviously didn't have synchronized audio, actors like Charlie Chaplin and Buster Keaton couldn't rely on dialogue to get a laugh or show emotion. They had to lean heavily into broad slapstick, visual sight gags, and highly precise character movements to tell their stories. The pratfall was literally the perfect cinematic tool for that era. So these legendary comedians quickly took this basic street hazard and evolved it into a complex narrative art form. Let's trace that. First up, Harold Lloyd used it in The Flirt. He tosses a peel, and a snooty, pretentious waiter slips on it. He's using the slide to take an arrogant character down a peg or two. Then you've got Buster Keaton in The High Sign. Keaton sees a peel, carefully steps over it, totally unharmed, totally subverting our expectations, and then he smugly mocks it, only to immediately slip on a second peel he didn't even see. Brilliant. Finally, Laurel and Hardy used the classic banana peel slip as the ultimate catalyst to kick off an epic, full-scale pie fight in The Battle of the Century. Which brings us to Section 2, Cartoon Physics and Graphics Movements. Leaving live action behind, we enter the totally limitless world of animation. Animation has basically built an entire extensive vocabulary of visual tropes relying on this one single fruit. In this medium, graphics movements just constantly reinvent the physics of the fall. We get the classic slippery skid, right, where a character's legs turn into an absolute blur. We've got the circling birdies, or little stars floating around a head to show a concussion. There's the trash landings, a hilarious nod to those old New York City sanitation problems, where a character slips and just inevitably lands headfirst in a garbage can. And, we can't forget the unavoidable modern hazard of dropping a banana peel on the track in Mario Kart to send whoever's behind you into a wild spin. Sometimes, after the crash, the character even ends up wearing the peel as a kind of improvised hat. Moving on to Section 3, scoring the slide with whistles. To really grasp these graphics movements, we've got to talk about how we actually hear them. Enter the slide whistle. Now, technically, it's an aerophone fipple flute from the 19th century. Inside its cylindrical tube, there's a little piston. When you blow into it and pull that piston, it creates these continuous, smooth, gliding pitch variations. Musicians call them glissandos. Because it doesn't have fixed pitches like a piano, it is the absolute perfect auditory equivalent to losing your physical balance. When a cartoon character's feet fly out from under them, that pitch swoops right along with their trajectory. And the contrast here is just massive. In traditional orchestras, the slide whistle was occasionally used for, avant-garde exploration or setting up these mysterious, eerie soundscapes. But over in vaudeville and cartoons,
Oh, it became the undisputed king of humorous sound effects. It scores the exaggerated falling, the sudden slipping, and it pairs just flawlessly with whimsical visual gags, turning the slide into this totally multisensory experience.
Let's pivot to Section 4, the science of the slide. Yes, we are treating this incredibly silly trope with deadpan scientific reverence, diving into the actual tribology, which is the study of friction. Okay, so the crucial number here is shockingly low, 0.066. This is the coefficient of dynamic friction, and it was discovered by Japanese researcher Kiyoshi Mabuchi in a 2014 study that actually won an Ig Nobel Prize. His team literally took Cavendish banana peels, placed them inside down on linoleum, stepped on them, and precisely measured the horizontal and vertical forces using a force transducer. Talk about commitment to a bit. So let's put that number into perspective. Rubber on concrete? That's a super grippy 1.02. A tangerine peel clocks in at 0.225, which is honestly about as slippery as bare wood. But the banana peel at 0.066? That is almost as slippery as pure unadulterated ice, which sits at 0.05, or even Teflon at 0.04. Here's what's happening. When a shoe crushes the inside of a banana peel, it turns its polysaccharide follicular gel into what's called a homogeneous sol. Basically, it creates a perfectly smooth, ultra-lubricated surface. The old myth? Yeah, mathematically, it's 100% real. Actually, the physics are so incredibly reliable that modern tribological studies are taking the peels of the Musa acuminata banana and extracting them into a broth. This broth is a high-viscosity, biodegradable liquid. It's literally being tested right now as an eco-friendly industrial biolubricant for heavy machinery. So the exact same mechanism that violently downs a cartoon character might, one day, be lubricating an industrial engine. How cool is that? And that brings us to our final part, Section 5, the psychology of laughter. We're left with a truly fascinating contradiction. If slipping is mathematically dangerous and highly frictionless, why do our brains instantly force us to laugh? Well, the answer lies in something called the play frame. This concept was coined by Dr. William F. Fry, who founded gelotology. Yep, there is a science of laughter. The play frame is basically a psychological context that frames a real-life event as non-serious. If we see someone fall out of a 6-story window, that's a tragedy. Our internal alarm bells ring. But if we see someone experience a sudden, clumsy character movement and just slip on the street, assuming they're just terribly embarrassed and not actually hurt, the play frame kicks in. It prompts amusement, maybe a little dash of schadenfreude to where we take a tiny bit of pleasure in their minor misfortune, but it actually goes even deeper than that. Philosopher Henri Bergson theorized that we laugh at people who ignore their surroundings as a subconscious way to enforce societal rules. We're reacting to the sudden incongruity, the totally careless behavior. By laughing at someone who isn't paying attention to where they're walking, society's essentially punishing their carelessness and nudging them to, be normal. Laughter, in this sense, is our biological way of regulating the herd. Which leaves us with one final provocative question. If slipping on a banana peel is a mathematically proven hazard that perfectly mimics the friction of ice, why is our absolute first instinct to laugh rather than help? I think it's a huge testament to how art, culture, and those classic graphics movements have utterly rewired our brains to see physical danger as pure entertainment. Thanks so much for joining me on this explainer today, and hey, next time you see a yellow peel on the sidewalk, maybe just go ahead and step around it. Catch you next time.